All right. So yeah, let's begin. If anyone has a question, you can just call my attention anytime or type out in the chat. But uh, my chat is on the other side of the monitor, so I can't really see it immediately. So if you have some microphones, you can just call my attention. Okay. All right. Let's move this window here. Oh, my windows. Okay. Linear regression, right? So let's have a brief review of what this is, and then proceed to some examples later on. Okay. After that, um, yeah, we'll see if it takes us an hour or so. Then maybe we can take a break. After that, we'll proceed to supervised learning. Okay. So regression analysis is one of the most widely used methods of prediction. So this is actually a statistical technique, right? It comes from the statistics used to model and analyze the relationship between a dependent variable, also known as a uh, response, and one of the independent, also known as the predictors or the features. Okay. Now the primary goal of the regression analysis is to understand, right? And if we can, I didn't have a laser. If we can quantify the relationship between the variables, make predictions, and then see if there's a pattern in the data. Okay. So there are many types of regression analysis. So we have simple linear, we have multiple linear, we have even polynomial linear and logistics regression. Okay. But basically it could be something like this, cause and effect. So um yeah, let's start first with something simple. So we have here in this image we have a statement. So the amount of money you spend depends on the amount of money you earn. So we're all trying to see if this is actually true, right? If this is a cause and effect, as per the previous slide. So in the context of regression analysis here, um, we are implying that there's a relationship between the two variables. So spending, that is the dependent, and earnings, right? That is the independent variable. Um, so that's what we are, that's where we are at right now. Okay. However, um, what you guys need to remember is that it's important to note um, that the statement itself, when you read it carefully, it does not imply directly causation, right? It doesn't say that um, directly increasing your spending increases the amount that you earn, okay, or vice versa. Um, it simply suggests an association, or the correct term would be a correlation between the two variables. So they are somehow related in a way. When you saw the data that you have, okay, still like. So what is a linear regression? So this is the most basic description that we can have. A linear regression is a linear approximation of the causal relationship between two or more variables. So basically, we're looking for the equation itself that can describe their relationship. That's it, right? So the process of creating a linear regression. So these are the generic steps. So first is get some sample data. Next is design a model that works for that sample. And then third is make predictions for the whole population. So this is a very generalized process, right? But if we expand this one, we can add some more steps. So um, first is you have to clearly define the problem. Um, define the problem that you are trying to solve. So That includes identifying what is the dependent, what is the independent, and so on and so forth. After that, there's a yeah, we could go ahead to the sample data, collect data, ensure that the data is representative of what we're trying to uh, get the result of. Make sure it's clean, contains observations for both variables that we are taking into account. Okay. So good data, a quality data. What else? We can add a step of pre-processing data if we want, but I guess that's also included in the sample data. This is the part where we will um, handle missing values, outliers, any pre-processing tasks that is included with data. So basically, we're just cleaning up. Okay. Next is we're gonna split the data. So dividing it into training and testing. We've done this the one last week with the random tree or with the decision tree, right? Remember? So you're gonna split your data in order to save time, split it to training and testing. Okay. Next is design and model or choose a model. So then we're at step two. If we choose linear regression, um, we have one dependent, right, and one independent. So this means that it is a simple linear regression, one dependent, one independent. If you have multiple independent variables, that is considered a multiple linear regression. So you can go ahead and research those other regression methods, but um, basically, if you understand how to do the first one, the others are actually just an offshoot of how to do the first one. So it's really um, just a few more steps, and you're able to do the other models as well. After design model, of course, we have to train the model. So we're going to use the training set to fit the linear regression model, right? We're gonna estimate the coefficients. Remember the constants that is in our equation, and then the slope and the intercept, ax plus y, right? So the a is the slope, y is the intercept, if you remember. And then you test, right? Um, you test and then get predictions, right? Okay. Then what did we do? For the decision tree, what did we do at the end? We used some common evaluation metrics, right? Like the R1, uh, there was what I forgot that we used the MSE. Yeah, that's one, mean squared error. There's the R squared, of course. So yeah, we're just gonna use the common validation metrics to see if our model matches our data. Next is one of the most critical parts is to actually interpret the results. So it's gonna give you a lot of points, right? The predictions, and then you're gonna see the data as a whole in a graph of your choosing. And then you're going to interpret the coefficients, their significance, understand their relationships if it's a positive slope, a negative slope, right? And then yeah, once you're satisfied with your model, right, you can actually go ahead and make predictions. Okay, you're gonna use your model to make precision decisions for unseen data, right? And then finally comes to the test data that you split earlier. You're gonna compare that one with the predictions that your model has made, and then see the results if they are the same. How close are they, right? With the prediction of the actual result itself. And then you can gain more insights from that. and get more conclusions per se. All right, so here is the dependent predictor and an independent predictor. So dependent is symbolized by y. Independent is the function of x1 up until x of k. Independent variable y is a function of the independent variables x1 to xk. Right? This is a very general mathematics formula for linear regression. And here is a simple linear regression model. All right. Now it looks a bit weird. Yep, it's using different character symbols, but essentially it's still the same as what you've learned before. So y is supposed to forgot if this is beta. I don't think this is beta. I'll just call this one B. B0 plus B1, X1 plus epsilon. So X1 here is the independent variable. So B0 here is the intercept, right? This represents the baseline of y when x is 0. B1 is the slope, okay? Um, if you think about it, you can just interchange them and it looks really similar to what we've learned before. Okay. Uh, so the slope indicating the change of y with the change of x. Okay. E here, epsilon is the error term. So this represents the unobserved factors influencing our dependent variable. So yeah, something like unforeseen circumstances, stuff like that. So in this hypothetical model, right, a positive B1 would imply what? That as earnings increase, okay, spending will also increase. That's what we're trying to say. While if B1 is negative, right, we would also have negative spending or a lower amount of spending. So regression analysis allows us to estimate these coefficients, assess the significance of relationships, and make predictions for y based on values of x. Okay. Providing a linear regression example. Okay. So here's another cause and effect example, right? But it's not really stated that way, more like it's kind of that's the test that we're trying to see if there is a relationship between education and income. Okay. So basically, um, we can say that although education has an impact in once income, it does not necessarily equate immediately to a higher income, right? So there are a lot of things that can happen in between, right? One is you could fail your education. What else? Money concerns, of course. What if you don't have enough money for education, right? It's really expensive to go to college these days. So that can be one factor, right? That you cannot get education. So it's not always education, guarantees higher income, but it does increase its chances from what we know, right? What we see, in our day-to-day lives. So let's see. In our data here, in our sample data, right, we can see that more education translates into a higher income. Okay. Uh, let's see. For each additional year of education, okay, each time that we increase X1 by 1, your income will increase from 3,000 to 5,000. So this quantifies the effect of education on income. So okay, yeah, we'll get to this later on in the end. Okay, it will be clear right at the end. Uh, I think. So the constant here, the other two components are the constant BO and the other epsilon. So there's a constant. All right, so if you have no education, so that means 5,000 times 0 is 0. And assuming epsilon is just negligible. BO is basically our minimum wage. All right. So that makes sense. Um, this is somewhere on the y-axis, our minimum wage. All right. But we can't have, can we have negative education? I don't think so. Oh, mm, I don't think so. So let's see. Oh, yeah, it's already here. On average, error, okay, is usually negligible. So we can just delete this one and then just stick with BL plus B1 X1. So whether epsilon is there or not, it won't actually be that much of a difference, right? So we're left with this very basic, simple linear regression equation. So now you can see that it looks exactly like the one that we've had before. Okay. Um, let's go ahead and do a simple linear regression example. Um, we're not going to use we're not going to use a data set yet. I'm just going to show you a quick example of how to do this in linear regression. All right, what are the things that we need, the things that we will import, and see if it will work. Okay. All right. So, okay. So what do we need to do first? We need to, the keyboard is not working. Okay. Import numpy as numpg. If you guys are on your Anaconda Dribbling notebook, please follow along and see if it works on your end. Okay. You also need pandas as PD. NumPy and pandas are for modifying the dataset and of course for the models to work. We're going to use matplotlib, matplot for the graphs from a scale-learn model. You will get it from a selection. We're going to import the train as split, right? From a scale-learn linear model. Linear model, we're going to import linear regression. So I don't know if you guys can see the similarities between what we're doing here and what we're doing before in uh, precision tree. Okay. But later on when we go to the actual supervised learning, we're going to be using an actual data set, a big data set, so that you guys can see how it actually works in real time. Um, Next is from sklearn. We're gonna get the metrics. Gonna import just two, maybe mean squared error, and then R2 score. Yeah, we're just gonna use these two things. Okay. Next is, let's see. Okay. Let's generate a random data. So we'll go to NumPy and then random. So we'll use the seed of 42. The seed is so that anytime that we rerun the program, it will produce the same result. That's the importance. It's for reproducibility. If you don't have the seed, then every time you run the program, it will create a different data set, right? We're gonna save this one and the independent variable x. We'll just call it x and then np.random rand. Rand is the method we're gonna use. So I'm not gonna discuss any more methods, functions. Okay, should be done with this one, and you should be familiar with what they are by now, right? Um, np-random.rand. This has a method. This method is for creating numbers, so 101, and then we'll just multiply it with 10. Okay, let's add some noise. So noise is equals to np.random.rand n 100, 1, and then 2. Okay. So linear relationship with noise. So, what can we do next? So we can see after creating some. Let's try and set the uh, model that we are trying to mm, compare with. So if we say y, right? I think I'll just use a smaller x. It's easier. Um, y, right? Let's say our ideal linear model that we're trying to match is this one. So 3x plus 5 plus x. This is the model we're trying to match with, right? This is what will create the data. And then later on, we're gonna try and match our approximation of the number three and the number five, and we'll see how close they are. Okay, that's the main point, right? But in reality, you don't have this one. Okay, this is what we are trying to match against. This is what we're trying to look for. In here, since I am using just generated data, I have to base y out of something. So I'm using this uh, linear equation that yeah, we can compare later on as well. Okay, next is we'll create a data frame. We'll save it to data. So pd.data frame. Let's see, 2 columns. All right, so you need to flatten them out. Let's see. X is x dot random, and then y is y dot flat. So basically, I'm just preparing the random data that we get here. But in actual data science process, you don't have to do this because usually your data is already in the format that you want, right? The columns are already prepared, the rows, right? The data is all set. And in this case, we're just creating the data. Um, we're just creating artificial data. Okay. So we have the data itself. We need to split them out. So X train, X test, and then Y train, Y test is equals to train test split. We're gonna pass in the X, the Y, uh, what else? We're gonna pass in train tests, test size is equals to 0.2. And the last one is random state. Random state 42. Right. So the random state is the same as the seed that we had here. It ensures um, reproducibility. So every time you run the program, it will produce the same result. Okay. So we have test size, all right, 20%. It's good. Next is we're gonna call in the linear regression model. So model is equals to linear regression, the same as us calling the decision tree before, right? We're just calling the name itself. Next is we're gonna fit the data, model.fit, X train, and then Y train. Next is we're gonna make a prediction, right? So my prediction will let Y pred, and then model predict. Oh yeah, we're gonna use the test side now. Test side. Test side. So as you can see, it can get like a little confusing, right? Just make sure that you're making appropriate variable names so that you won't get lost. So we have our prediction. We have our test text is we need to compare our result to our by test, right? So we're gonna use the MSV. So this is the mean squared error, and then we're gonna call it mean squared error. This one just needs two things. It needs the Y test, and it also needs the Y prediction. So we'll compare the one that our model predicted to the one that we have as a test, our test data. And then R2, we'll save it to R2 itself. R2, our score, it's a score, Y test, and then Y predict. Okay. So in here, I'm manually calling the names of the metrics that we're trying to use. Okay. I think last time I did this one. Let's see. It's happening. Predictions, decision tree. Okay, we're just using the accuracy score before. Yeah. Okay. So as you can see, it's fairly similar, right? Starting from the train part, right? X and Y data. Um, the way that we get the model is kind of similar. Okay. Last but not the least, we're gonna what do you guys think it's missing? We're missing the plot. So we're gonna plot all of these things, assuming that we did not make a mistake, right? Uh, PLT. So we're gonna use a scatter plot is the best one for this. Uh, Scatter plot, that's also one of the trickiest part in data science. It's choosing what plot to use. Depending on the data that you have, the best plot that can be applied differs, right? And depending on the plot that you choose, the story that it tells differs as well. So you have to pick the right one. X test, so I'm going to scatter the X test and the Y test. So Y underscore test. I'm going to set this one to the color of black. And then I'm labeling this one as true data because this is the true data, right? That came from our random generation formulas at the top. So this is our true data, right? And then after this, we're gonna plot it out, plot. If we're gonna plot this one, it will need tests, but instead of the y test, we're gonna use the y depiction. We'll use the color of blue. Uh, let's have some other properties here. We can set the line width to 3 if we want, and then add some label in the end with regression line for, yeah. PLT, the next table, we'll name this one as X. Very straightforward. PLT, the Y label. It looks like it's a lot of work, but we're actually just setting up the graph. PLT dot legend, so that it will display how it will help us maybe reading the plot, and then PLT dot show. All right, let's see. Mhm. All right. So invalid decimal literal. Hmm. Oh yeah, we're supposed to multiply this with uh, okay, import matplotlib as uh, plot. So it's still running. Okay. Line label has no label. Let's try and go. I have a lot of pairs. Okay. So this is one disadvantage of using Jupyter Notebook. So I myself use uh, Visual Studio Code a lot more than Jupyter Notebook. Mainly because it has a lot of features that makes programming a little bit easier. So uh, first, it detects very early on uh, wrong spelling, like this one way label legend, if those methods exist or not. So you can fix them early on. So that's one thing that Anaconda Jubilee Notebook doesn't have, but that's okay. It has other advantages as well compared to Visual Studio. And that is, it's actually a lot easier here to just quickly set up a Python environment and then just directly run it. All right, so we have our legend here, true data, the dot. Regression line is our prediction. Okay, so let's see. Mm, wait. I think it's missing something. Oh yeah, we did not print out the uh we did not actually print out the coefficients, right? Yeah, we just let's see. Shit. All right. Let's analyze the graph later on. Let's add some more things here. Let's mm, print the coefficients. Let's coefficients. Mhm. Model that coefficients under model that coef. And what else do we need? We need to see the intercept for. this one, right? The number five. Um, this is found under model dot intercept. Okay. So this is how you get those things, by the way. The number three here, the part B1, that's B1, right? It's under model.cof if your variable is named model. So depending on where you are using the linear regression function on, okay? Because you can just change the variable name. Um, for the intercept, the B1, no, the BO, that's the number five here. You get it under intercept, the intercept property. So like an underscore. Next case, we need what else? Mean squared error. We're gonna print this one out. This is just the MSE. And then finally, R squared is R2. R2, right? Mhm. Right. Okay. All right. So first is let's see the coefficient and the intercept. So this is our ideal model. Remember, this is what created the y dependent values. Okay. Now, in our model, using our data, random data that we created here, we were able to determine that the coefficient that the model computed was 2.9. This was the coefficient that it arrived at. The intercept, or 5 here, the one that it got is 5.28, right? So it's, if you ask me, it's pretty close, right? The mean squared error is at 2.6, and the R squared is 0.96. Now, what do these things mean? Let's start with the R squared. Now, um, if I were to ask you, is the R squared metric good? Okay, so um, you're gonna be the one that translate this one on your projects, right? So is that good? Well, it depends on the context of your problem. So whether or not that score is good depends on the use case, okay? But in general, right? If you have an R squared value of zero point 0.5, that is seen as an okay value generally. Zero point 0.5 is an okay value. Um, what does that mean? So that means if you have a zero point 0.5, it would mean that half of the dependent variable values that you got can be explained by the model, which means that your model predicted accurately half of the data. That's what it means. So your model is that good. It predicted half. Okay. So if we say that your R squared value is about 0.75, okay, that would be considered a um, strong correlation, right? Um, your model is actually really, really close to the actual thing, right? Now, what we see here is 0.96, which is very, very difficult to get in real life in an actual data science project, an actual data set. So this is far from uh, what you will get in an actual project. But it's also nice to see that since we were able to get this one because we created it randomly, and then it's it's not really um an actual data that we got, right? We just created that one out of using NumPy. Well, what about for the mean mean squared error? So this is a metric um, that we use to get the average squared difference between the actual observed value and then the predicted value. So the actual mean squared difference between them. So a good MSE is one that is low and close to zero. So the closer you are to zero, the better your model. Okay. But again, the definition of good depends on the context and the problem at hand. So a perfect score, if you were to think about it, would be a value of zero. So that means if it was zero, your model predicts exactly all the values on your test data. That's what it means. So seeing that we have a value of two, right? And you can also observe this one on our plot line. The dots are not really that far off from the line. See, only one, two, about two is just that's a bit far. But generally this kind of result is very hard to get. Okay. Um, right. So yeah. What else can we get from here? Mm. So if you were to write this one out as a formula, okay, and then compare it to y here, it would what? It would look something like this. We're just gonna comment this one out. It would look like y is equals to 2.9. I'm just gonna round it off 92 x plus 5.2. This is the actual equation that our model generated. Model, and this is the ADO, right? This is what we are really trying to do as data scientists, right? We're trying to create a model that accurately predicts the data that we have. Okay. That's why the more data that we have, uh, the more leeway our model has in going up and down those coefficients and get the correct value. If our data is too random, right? Like there's lots of ups and downs. It's not really like you can't at first look you can directly see that there's a relationship between as the x goes to the right, the y is also increasing, right? You can directly see that here. Um, but if your data is like scattered all over, then that's gonna be very difficult. Odds are maybe you're defining the dependent and independent variable incorrectly, or you're using the wrong graph. So you have to reassess yourself and go back to the beginning, try to see where you could have gone wrong, or maybe you were asking the wrong questions, the wrong problem at the very start. So, but that's okay, right? It's part of the process. You have to actually see, right? And, um, you know, gain insight from the data and see if it's actually if it makes sense or not. Because after this, right, with this model, we can actually go ahead and proceed with predicting more things that are outside of our test and train data. So since this is actually a really good model, we can use this one directly to predict things that will happen here, right here, at values of where the x is greater than 8, right? So you can go ahead and make predictions like um if we were to say like if X was the number of years, right? You could directly say in a presentation that so this means that our model is actually predicting uh about 96% of the data, right? It's that close. So we're very confident that in about another 2 years, another 4 years, um, we will reach these levels. So I'm sure you've heard those kinds of explanations before, right? Especially in um, like research and discussions, even in politics, you can hear that one that the data suggests that in 3 years, we will get to this similar to that one. So it's actually data science. All right. Or uh yeah. Anyway, we can also do that in data analytics, but yeah, it's data science because if you're predicting something, you're gonna have to use a model. All right. Any questions so far with this one? The code, um, the one that we did here, anything? All right. Okay. So I'm gonna treat that one as everything's clear. Okay. No questions asked. All right. Okay. So we're done with this one. That's officially the last PowerPoint that we have. Um, yeah. So now, let's see. I'm gonna go back to our previous PowerPoint. It's this one, right? So we have supervised learning, and then we're gonna try and see what we can do with supervised learning and some examples as well, right? So where do we start? Here, right? Hmm, let's see. Okay. Oh, guys, I'm looking for our uh data set that we're going to use. I seem to have lost it. All right. Since I'm still looking for the data set, let's have a quick break. 10-minute break. That should be enough time for me to look for it. Okay, guys. So let's have a quick break. Be back here by 2:20, and then we'll continue afterwards. Okay. Where did I? Right. See you guys. All right. So I hope you guys are back. So I managed to find our uh, data set we're going to be using. And I'm going to upload it now to our LMS so that you guys can follow along and download it on our side. Right. Okay. So it's the one named the flights data set. So yeah, it should be available on your end now. So just go ahead and download that one and we're going to be using that. Okay. Just put it in your root folder where your notebook is saved. It should be there right now. All right. Let me share again my screen. Mm, Okay. All right. Okay, so if you're looking at my screen, this is how you should set up the flights data set. So this is my notebook, this one that I'm using. And you should put the flights data set here on the root folder where you save your notebook to make it easier for us to access later on. Um, okay. So we're done with linear regression, right? We were able to see how to make linear regression work. So in our um, other algorithms here, we have logistic regression, we have decision tree, right? Random forest and K nearest neighbor. So we'll go ahead and use all the other things right now. So we're done with linear. Decision tree, we're done with this, but yeah, we can go ahead and do another one for now. But basically, I'm just gonna show you guys how easy it is to switch between different algorithms to create your models. All right, so we're gonna be using the last four. So logistic regression, decision tree, random forest, and the key nearest neighbors. All right. So there's no paper half. No paper. No paper. So just like usual, we're gonna have to import something as first, right? Let's start by importing pandas. Technically, I can skip this one, but I'm showing you how to do this as if you're starting on a fresh notebook. Okay, because if you guys remember what you have done on other cells can also be carried over to other cells. So if I have imported pandas here, technically I should I should not do this one here because it's just redundant. But I'm showing you guys how to code this one as if it's a fresh Jupyter notebook. Okay. All right. So we're gonna be using four algorithms, and then we're gonna need some other things as well. So from sklearn model, we're gonna use the selection again from, oh no, wait, not from import. Import train test split, and then pre-processing. All right. So there are some tools in sklearn we can use to help us in processing our data before passing it to the algorithm, right? So that's one of the good great things that we can use is the one hot encoder. I'll explain this one how it works, and the standard scaler. All right. What else? So sklearn dot compose. We can import the something called the column transformer. Very, very helpful tool. From sklearn, uh, under pipeline, we can import pipeline itself. So more in these things later as we are using that. Right now, we're just importing the things we need. Okay. Sklearn, linear model, import, logistic SOS regression. On sklearn dot tree, I'm gonna import decision tree classifier. Okay. From sklearn dot ensemble, we're gonna import random forest classifier of space forest classifier. And then that's it. From sklearn again. Dot neighbors import a neighbors classifier. And then finally, last but not the least, sklearn dot metrics import classification classification import. All right. So these are all the things that we need mm, for this data set. All right. Oh, by the way, did any of you guys try the code earlier? This one? Did it work on your end? I just want to ask, just to be sure that it's also working on your end, that you were able to reproduce the same output. So if we're using the same seed, you should also have the same graph.
Hindi po, sir.
Yes, sir. Were you able to do it?
Hindi tapos, sir. Medyo mabilis yung ng monitor. Hindi makopya yung codes.
Okay. Do you want me to zoom in?
Ah, pwede naman, sir.
Okay.
Parang try namin, sir.
Okay. How about this one, sir? Can you read it now? Or do you want me to zoom further?
Pwede na, sir. Okay naman. Malinaw naman.
Okay. All right, let me know when anyone is done. And try it on their end. So Vince, Marielle, hey, Skate. Um, yeah, any updates on your end? Hello, anyone? So Vince, Marielle, it's your sister, and Kate. Hello, hello. Are you guys there?
Okay naman sa akin, sir. Ah, same with the result dun sa sir.
Okay. All right. Thank you, Sir Caesar. What about the others? Just want to make sure because maybe it's missing some libraries or you need some additional guidance on your end with your Anaconda. All right. So I'll take that as a uh okay sign for me to proceed. All right. So we'll just go ahead and continue with our code. Okay. All right. Just let me know in the chat or just call me attention if you have any questions or clarifications. Okay. Um, let's see. Standard scalars, singularity. All right. From here on out, let's see. We're gonna use the data set that I uploaded earlier. So it's this one. 6 flights data set. You can rename it if you want. First is we're gonna load this one up. So data, um, the read underscore CSV, and then 6 flights data set dot CSV data set. Okay. All right. So actually, let's take a look at what our CSV looks like here. Okay, so this is what's inside our CSV. You can open this one up directly from your Jupyter notebook. As you can see, this is what's inside of our data set. So we have these columns. We have a year, the month, the day, the departure time. This is the delay, the arrival time, delay, arrival delay, the carrier or the uh how do I say this? The airline that is for this flight. So this is UA. AA is American Airlines. UA is United Airlines, I think. I'm not sure with DL. Dallas, I think. So these are US flights. These are the tail numbers for each airplane. These are their flight numbers. The origin is in what country, right? They came from. So if they came from, let's say, let's look for something that we know here. JFK. Here's one Boston. I'm not really sure with what the others mean. Atlanta, ATL. So we can just go ahead and search for these acronyms online. I'm sure it's readily available. Australia. Anyway, other than that, so these are the origin and destination of each flight. How long was it on the air and the distance that they travel? What else do we see here? We have the hour, how long the flight was, and the minutes as well. So these are all the different data that we have, okay? And we can say this is actually pretty accurate data and of high quality because um odds are these come from directly the airports, right? How many rows of data do we have? So if we go directly to the end here, we have around 160,000 rows. So I'm sure this is just partial data at best. So it's only 160,000. I'm sure there's more than that in a year. This is only for 1 year, by the way, 2013. And it's from months. Okay, it says here there's 12, but I'm pretty sure it's more than 160,000 flights in a year. Um, but anyway, so this is what we'll be working on. And as you can imagine, it's very hard to work on 160,000 rows, right? So that's why we have to automate this one using Python and then create models out of it. Okay. So again, we'll be creating models using the last four algorithms that we have here. Okay. Uh, yeah, let's proceed. So that's PD. Yeah, let's try and see if I can actually access that one. Print data. I can. All right, so that's good. I'm able to print that. That means it's able to access the data. That's nice. What else do we need to do? Or we can go ahead and pre-process the data. So we can say data is equals to data dot drop NA. We can do a drop NA. So I'm not really sure if it has any, but if we go ahead and search this one, I think we can find some rows that have no values. Okay, so okay, so here's one. Okay, so these are the things that we want to remove. So if there's data that has NA on it, we can consider that one as bad data. It's not gonna affect. It's just gonna affect negatively our search, our research. So we can just go ahead and remove them or save them somewhere else and maybe we can find use for them later on. Okay. So, but in this case, I'm just gonna go ahead and delete those rows. Okay. After that, let's see. Mm, delete. Okay. Let's go ahead and classify each row with delete time. So we have arrival delay here, right? So if it's a positive value, that means it wasn't on time. It was late. If it was negative, it arrived earlier. So let's add another column for this arrival delay um, with values of only 1 and 0 to make it much simpler. So let's go ahead here. Let's see, data. I'm gonna create a new column. I'll call this one delayed, and this will either just be true or false or 1 and 0. So we're gonna say data, um, arrival delay. That's arrival delay, right? Okay. Are you late? Is greater than 0. Then what do we do? If this is, we will get the S type and then int. Okay, so this will essentially create um, values of 1 and 0. It's 1 if it's delayed, 0 if it's on time, and it will create an entire column uh, afterwards. So if you go ahead and print this one, you should be able to see a new column near the end. And as you can see, it's just ones and zeros. So it's easier to um, classify this one later on. So again, we're just processing the data for now. Next is we'll define the dependent and the features, right? We'll go ahead and say X. We'll just use X and Y to make it easier. Data. So these are our X values. It's actually what you can put here the depth delay, um, the distance, airtime. You can put here the hour, the minute, the carrier. Yeah, we can put the carrier. We can use the one hot encoder later on. It is next is the origin and then the destination. Same with that. Um, Y data would be data and then whether it was delayed or not. Okay. Um, so those are X and Y data. Okay. Next is we can use, oh no, wait. Let's identify first which are numerical columns and which are categorical columns. All right. So these are the different types of data. Before numerical features, so features, these are the following. So it's the depth delay. It's also the distance, the airtime, of course, hour, and the minutes. Um, categorical. These are the carrier, but we can change this one to numbers later on. Categorical or carrier, origin, and of course, destination as well. Okay, right. Next is we'll pass all of these things to our preprocessor. So preprocessor is equals to the column transform, right? So what does the column transformer do? Right. So basically it's gonna transform columns using used to, okay, into numbers, right? Because it's very difficult for algorithms to relate one row of data to another if they were text. So much better if we were to convert them into number equivalents and then in that way, they can read it as if it was the text itself, but it's just the equivalent. Let's say the MIA here is equal to 1, ATL is equals to 2. So they can use that one as a sort of way to access that information and then relate it to others as well. Because if it was just a text, then it can't do that. All right. So you go ahead and say transformers. This is how you use it, by the way. All right. Um, the num here is for the numerical. Right. What do we do here? For the numbers, this is where we will use the standard scalar. So the transformers will also write out uh, on each item the different things you want to do for each column. Okay. So standard scalar, this one. Next is what data is it looking at? It's looking at our num features. Okay. So what does the standard scalar do? The standard scalar here normalizes our data. Okay, so why do we need to normalize data? So imagine, oh no, you can actually see this one here. So, for example, this one, arrival time. Okay, we have an arrival time of a very large number, 2349, and a very number as well, 10. So extremes like this one, okay, is very difficult. It's actually very difficult to actually uh, put this one into a result because the numbers are too far apart, right? It's gonna impact the result because if one number is too big or one number is too small, it's gonna try and drag that out in the result, right? So the result will kind of shift towards the numbers that are too big or too small. So what we do is we standardize, right, their weights, per se. So the weight of the very large number and the weight of a very small number, right, will not affect all the other data that we have that is somewhere in between. So that's what we need to do. That's what the standard scalar does. Okay. The next one is the one hot encoder. So this is for that, short for categorical. So we're going to use the one hot encoder here. We can put the parameter of handle unknown to, I'm missing an error, to ignore uh, any kind of errors or um, anything that is, how do I say this one? Mm, not really errors, more like unseen category, that one. Okay. So if there's an unseen category that's different from the rest, it will just ignore it. Okay. Uh, and this will be using the ones on the columns for cat features. Let's see, what else do we need here? I think that's pretty much it. So again, the column transformer allows us to edit the columns and change their values to something else. All right. So in this case, the num features here, we're going to change their values into something else, as well as for the categorical features. Actually, let's try and see the before and after. So print data here. And wait, let's put this one here. So that we can also see the delayed column. And then after processing the data, pre-processing the data, let's see what the data looks like now. All right. So we have, let's see, column transport pipeline. You can access this one later on the pipeline. I just want to see and compare the data. Let's try and see if we can access it. All right. There are 17 columns. Let's try and see. So it's just equating itself based on the function. All right. So it seems that we need to actually pass this one to the pipeline so we can see what's inside. But that's okay. Ideally, that's what is happening underneath the hood. Okay. Um, right. Next is we're gonna initialize the different models that we prepared earlier. Okay. So we're gonna say models, and then we're just gonna list them out here. Okay. So we're gonna loop over them later on and get the results one by one. So first is this is the logistic regression. Um, that we're just gonna call logistic regression. Mm, We're gonna put some parameters here later on. Okay, let's type them out first. Decision tree, then decision tree classifier. Next is the random forest. Random forest. What's this? Okay, because I see that first. Random forest classifier, and then finally KNN. K neighbors classifier. All right. So these are the four things that we're going to use, right? And we have imported these functions already. For the logistic regression, we're going to need the max iteration parameter. We'll set this one to 1000 for now. What is the max ITR? So basically, you set this one to help convergence, right? So if you have an error like it wasn't able to converge, then you can just increase this value in order for your algorithm to converge. For the decision tree, it's gonna need we can put the max depth here, and we'll set this one to 5. We'll set this one to 5. So the maximum depth of the tree, the decision tree. So basically, the rule of thumb here is that a small value, right, a smaller value prevents overfitting. So overfitting is you're basically forcing your model to fit to the data. So try to avoid this one. Um, Try to use lower numbers of max depth if possible, right? So these parameters are more of a trial and error, okay, until you can find that sweet spot. There are methods of looking for the exact values, but it's more trial and error as well. They're just more methodical in that sense, using those other ways of looking for the exact or good values for these parameters. For the random forest classifier, we're going to need the n estimators. Okay, so the n estimators, these are the numbers of trees per se in the forest. So more trees generally lead to better performance, but it also increases the computational load on your device. So more accurate, but it takes a while longer. So we'll just set this one to 100 for now. Um, all right. For the KNN, we're gonna need the N neighbors. Neighbors. Yeah. And I'm gonna set this one to 5. Okay. So the N neighbors, these are the number of nearest neighbors to consider for the classification. Okay. Um, so the higher the number, the more things it need around it, or in its neighboring area. That's why it's called neighbor, in order to be classified as one of those um, data points. Okay, so that's why it's called the neighbors classifier. It depends on the values around it. Okay, so these are the models that we're going to use. These are the parameters. Again, you can change the parameters until you see the best fit. Next is we'll proceed to make a loop. So for name and model, in model of items, okay, we're going to get each one here, name and model, and we're going to do something with it. So CLF, we're going to call the pipeline here. All right. And steps. What are the steps that we need? So the steps that we will need are the following. Okay, so we're going to need a preprocessor. Pass this one here. And we'll also need the classifier, which is the model. Yeah, preprocessor. So, models of item. Gonna access one model at a time. Okay. Next is we have the train and the testing train, X test, Y train, Y test, and then train test split. We're gonna pass in our X's here, our Y's. Um, right, X, Y's. Let's split our data into 30%, 0.3, and then the random state point two. We'll just use point two. What else? So we have the pipeline now. So we can just go ahead and say CLF dot fit. Okay. So each time that we are using the CLF, um, it's gonna change the pacifier, right, to the next model on the object here. And the preprocessor will stay the same. It's still going to use the same thing. All right. So we're going to see fit. Mm, yeah. X train and then the Y train. After this, we'll make some predictions, just like with what we did with linear regression. Y prediction is equals to CLF dot predict X test. Test, yeah. Yeah. Then we can print out, let's see, put the slash n here, name, and then results, and then print classification report. on that specific algorithm, we're gonna pass in our Y test and then Y prediction to get the results. So these are the precision, the recall, the F1 score, and there's another one. Support, I think, is the support. So let's see. So it's gonna loop over this one with the model, different models, processor model thing. I think this will work. Hmm. Oh, max ITR, unexpected argument. ITR. Oh, okay, ITR, ITER, iteration. Why is there only two? Okay, let's just wait for it. I think it's still running. So we have the logistic, the decision. I think it's still running for the random forest and the KNN. So let's just wait for it. All right, so it's still white. So it's still busy. Let's wait for a while. So we know that it's still running. Yep. So hopefully it won't create an error. So actually it's taking quite a while, right? At the random forest part. Okay. Save it some more time. I don't think my Jupyter notebook has hung up because the time is still running. So we'll just observe for now. Oh, Sir Vince, you can download the data on the LMS. Okay. Let me go back here for now so that you guys can see the code. Anyway, it's still running. For the data, you can go ahead to LMS, my courses, and go to your course. So that's the batch 21, and then download this one, 6 flights dataset. So that's the one that I'm using, right? Okay, still gonna get done. So kindly try it out as well, Servants, on your side. Make sure that it's working and we get the same result. All right, so I got the result for the random forest. I'm still waiting for the K nearest neighbor, the KNN. All right, mine is still running the one for the KNN. So I'm currently at 500 seconds. So this also depends on your device. Okay, so if you have a lower end device, it's gonna take a lot longer. Um, so I have around mid spec for my device. So I'm not sure how much of an impact that will have, but it does have impact, right? I'm not sure how big of an impact is it. All right, so mine is done. So as you can see, let's go down here. It should display in this manner. So logistic regression, these are different results, decision tree result, or random forest result, and then KN result. So as you can see, we just looped over each model using the pipeline here and the for loop. So it's gonna change basically, what this means is that the pipeline is that while it's running, right, we can shift models when the previous one is done. So that's what the pipeline is for. We're feeding it the next thing. Um, and we prepared that one in advance before with our preprocessor variable here and the model variable. See? All right. Um, Now what do we got? So if you go now and take a look at the results, right? We have these things. So these things are what's inside the classification report. So it's everything that well, one of the basic things that we can get to directly see different results and compare each algorithm to each other. All right. Now let's start with the ones and zeros. Okay. So the ones and zeros here, they are the classes. All right. Or in this case, it's the what? This is our independent variable, right? We were declaring that one earlier here as the y data, right? Delayed. We added that column earlier and then defined it as our independent variable. This is our dependent variables. Oh, no, wait, I got that one mixed up. This is our, yeah, this is our dependent variable. This is our independent variables. Um, yeah. So let's see our results. So 0 and 1, these are the different classes in the delayed column. So there's only two, 1 and 0. That's what we did earlier, whether it's the flight is delayed or not, true or false. So we can see that in the classes, these are um the precision, the recall, the F1 score, and the support. Now the precision here, this is for um how many were actually that class, right? The zero class. Okay, so um, what does this mean? Uh, it's comparing everything that's truly zero, right? Versus the false positives, right? We have false positives. So a higher number of precision means a lower rate of false positives. So sometimes we get a value of zero that's not actually, that should be a different number, right? It should have been one, something like that. But in this case, it's not. We applied that formula earlier, right here, the AS type. So, uh, yeah, uh, since this is actually pretty high, okay, compared to the other algorithms, 0.78, 83, 81. So the one that it's similar to with it is random forest results. All right. So that's for the precision. The recall is actually similar to precision, but instead we're trying to detect for the false negatives, all right? So these are the numbers that should have been positive, but we detected them as negatives. All right. So there's a formula for this if you want to know. For the false positives, it's about the number of true positives divided by how many true positives over true positives plus the false positives. That's what we get, or the total itself. And then that's the ratio that you will get. Okay, so again, the higher the number based on that ratio, the lower the amount of false positives. The same thing with the recall. The higher the number, the lower the amount of false negatives. So this is actually good values. F1 score. The F1 score is the harmonic mean. All right. So you can go ahead and search this one. So this is a statistics term, harmonic mean. Uh, this is harmonic mean of precision and recall. So it is a single score, right? A single value that provides a balance between the two, which is precision and recall. Okay. Uh, so a bigger value actually means a better balance between the two. All right. That means not the other one is not too big of false negatives, and then the other one is not too small of false positives. Something like that. So if it's a good balance, that means the result is also good. Accuracy. Let's see. Accuracy. Let's see. Oh, these numbers, by the way, at the end, indicates that there are 30,391 instances of the class zero, and then 60,988 instances of the class one. This is what support means. Okay. Right. So how do we read this one? Let's go now to accuracy. Now, accuracy here. Let's see. Mm, I'd actually discuss this one. But accuracy is basically the overall proportion of correct predictions across all the classes. So there's only two, right? Um, so we can calculate this one as the number of true positives together with the true negatives, so add them both over the total samples. That's the accuracy. Um, so we can get that one directly here in the F1 score. True positives and true negatives over true samples. If you add them together, let's see, I'm gonna get my calculator. It's 30. 30, 391 plus 16,988. That is 47,379. Okay. So it's the number here at the end. That's the total number of samples. So the ratio between them, all right, the total true positives and true negatives divided by this one is 0.84. That's what you get. Okay. Next is the macro average, right? Now the macro average is the unweighted average. That's the description that it gives um, on the site. So you can learn more about this if you want. Just go to sklearn, or there are a lot of resources online. But generally, macro average is the unweighted average of the metric, precision, recall, or the F1 score for each class. All right. So it's the unweighted average. So this is what we got. So 80, 2078. Um, and of course, weighted is of course the opposite of the macro. So you gotta weight them out. Okay, let's try and analyze this one. Um, let's start with the logistical question, right? So if we observe it carefully, logistics regression, right? Has the highest overall accuracy. It's 0.84, which is actually pretty big, right? It also has the highest weighted average, 0.84, 84, and 83, especially in the F1 score, since this is the what the ratio of precision and recall, if you remember. So this matters more, the F1 score. So it's the biggest out of the three, as you can see. Mm, okay. 7.119. Right. Just by observing the average, just by observing the average and the accuracy, we can also say, right? We're gaining some insight on our data here. We can also say that the model for logistic regression has the best performance, right? High precision, it has high recall. Um, so a good balance between the two. This is actually for the K and NSPC, they're too far off. Also for this, mm, but it's pretty high, so it's more zeros, right? It's predicting more zeros correctly than the other algorithms, CSC78. So it's performing better than the rest. That's for class zero only. For class one, let's see. Mm, it's a little low, right? For class one. It has good precision, but a lower recall. This means that um, while its prediction for class one is quite high, right? It misses a significant number of class one instances. So that's what we call the false negative. Um, that's what it means. So higher, lower. Again, this is what the F1 score is. So a good balance between high and low actually means a better performance algorithm. So as you can see here, 72, 74, 70, right? This one is clearly the winner at this point in our for this data set. What about the decision tree? So the decision tree, the one that it's good at is for the recall. So it has a high recall value, um, but lower weighted score, right? And the precision is also a bit low. So it's not that good. So what does this mean? Especially for this one, for the class one, it's 0.51. This indicates what? That it has a severe bias towards predicting more values of zeros than ones. All right. And that means it fails to identify about half of the instances that we have in our test data. So, uh, yeah, it's more biased towards predicting that or values that are zeros. So this one is 66, is 51, 69. So random forest actually has the highest recall for class one. KN is just about there, 63. Okay, what else can we get from this? So random forest is actually pretty good as well. 83, 88, 86. It's pretty balanced, but this is clearly better for zero. For the ones, it's a bit higher, but it's lower under precision. That's why it has a lower F1 score. Um, and because of that, it has a lower weighted average. But overall, it's kind of similar to what we have in logistic regression, right? And what else? Mm, 3, 86, 86, 85, 64, 72, 72. If you compare this one to decision tree and KNN, Random Forest is better. Okay, let's see a trade-off here.
No, 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 no. That's not this one.
Actually, KNN is actually almost very similar to Random Forest as well. With the weighted of just 0.01 difference. So their performance is about the same. So either one that you use, they will have the similar results. Okay, I think that's all about that we can get from this. So let's summarize those things again. So for logistics regression, we have the highest accuracy among the four. So it also has the best recall, 93. Um, oh no, wait, decision tree has the highest one. Okay. Oh no, wait. Best accuracy 84. Yep. So considering the precision and the recall, right? Logistics regression has the highest accuracy for predicting class zero. Okay. Um, it's point me. This is a for the decision tree. Um, it has 0.79 accuracy. So if we identify every possible class zero instance, so that means a high recall, high precision. But this has again more bias to predicting values of zero than one, because here it's predicting it's missing out false positives for one, false negatives for one. So it should have been zero. That's why it's more biased towards uh predicting values of a zero. So that's not really what we want, right? For the random forest, let's see. In terms of F1, let's see. It seems that 72 systems or 81, 83. Six, nine, 76. Class zero is 93 and 28. So for random forest, we can say it has a good balance for predicting values of zeros and ones. That's the only thing that we can get from this. Um, for KNN, again, it's similar to random forest, but it's weaker in predicting values of one, clearly evident here, 69 and 63. And that's it. That's really it. Everything else, they're similar. Okay, so it's rather difficult to just read the results from this, right? It actually, if we take some time with this, we can get more things out of it. If we really deep dive into each one and really compare the result to each other, then um, we can proceed to choosing the correct model for our data set here. But as of right now, the best one is logistic regression, right? It's the most basic one of the most basic ones, and it's very often used actually. So using this is actually a very safe bet in predicting whether a flight will be delayed or not in the future, right? So let's see. How about for choosing a model, right? So what are the basis for choosing? It's not just because logistics is the best, right? So if we choose a model, um, it actually depends on the kind of goal that we have, right? So for if we want to choose logistics regression, that means you need the highest overall performance and more concerned about correctly identifying more values of zero because this is the highest one, right? It can highest value for recall. Um, if you need a better balance and is willing to sacrifice a little accuracy, right? Uh, to be more robust in predicting values of one. That is, it's more balanced to predicting ones and zeros, and the trade-off of it is the accuracy. Then you can go ahead and go to random forest, right? Because this has a higher value of recall for it, one, compared to logistics, right? But you have to, take uh sacrifice the accuracy for predicting the zeros a little bit, um, to get a more better balance in predicting with zero and one. Okay. So it's a better balance because they're closer to each other, right? Uh, this is actually quite far off from each other. Okay. So it's not really that balanced. So we can say that random forest is more robust. If that is your goal, then it's more ideal to use random forest. We should avoid decision tree unless your specific goal is to maximize um, the results for zeros. Okay. Um, because the performance here for class one is actually very poor. So if you're gonna use the decision tree, it will lean more to predicting values of zero. And if the only case I think you can use this one is for the worst case scenario. I mean, if you can think of a worst case scenario, then maybe we can use the decision tree. K and N, you can swap them out with random forest, but it leads more, right, to uh it depends more on the balance. So in this case, recall, right? Yeah, the random forest has a better balance compared to the KNN, but other than that, all the other results are almost similar. Okay, especially with the accuracy here. You can see it on the journal overview. The accuracy, the macro, and the weighted, they're almost exactly the same. So that's one way of measuring it. Um, yeah, I think that's it for supervised learning. So again, this is how you um, import those algorithms to your program, right? Just import them directly. Logistic, decision for customer, random forest, key neighbors, and the classification report. You can learn more about this, right? If you visit the SK Learn documentation, right? If ever you get lost, that's where I go always. I always go to the documentation, read, and then apply what you have learned. So yeah, again, programming is more about reading. It's not really about how fast you program. It's more definitely more reading, from my experience. So I have fewer and fewer time to code than reading. So I read a lot of documentation, codes that are made by others, and then I try to apply their logic to my logic, something like that. All right. So the more that you repeat those things, right? The more that you use them, that's the time that memorization comes in. So you can memorize like the different parameters, so on and so forth, the basic default values that you can think of for these things, and then just modify them later on to change the results that you want. Okay. Again, we can change these results if we also change these parameters, right? Um, okay, remember the things to avoid. Avoid overfitting. That is, you are forcing your model to fit the data that you have. That's the one thing that you don't want. Um, avoid having too much data, right? Focus on getting more quality data than quantity. Um, what else? I think that's it for now. Right. So next is, okay, we can go ahead to unsupervised learning. Okay, but it's already 4. Let's see what else we can do. Mm, and I think this is good to do. Um, Let me ask you guys, you only did one web scraping activity, right? Because I want to reserve um discussing this, right? Unsupervised learning, because this is quite long compared to supervised learning, and this will take up around 2 to 3 hours, I think, of our time if we were to discuss this. So if we discuss this right now, we're just going to be cut off in the middle. So if we do this next week, we can finish it entirely. So I was thinking that on the next hour, what we can do is to have another example of web scraping activity. Would you guys like that? Or all right, so that's an okay from Sir Caesar. How about the others? Are you okay with that idea? Because we haven't we just touched the concept of web scraping. We haven't actually explored all the other possibilities with that. There's of course dynamic web pages. We haven't even logged in those kinds of things, right? Pages that refreshes itself. So there's a lot of challenges when you are trying to scrape the web. All right. So yeah, we'll do that after a quick break. So this is our last break for this session, and then we'll continue until 5. Hopefully we can finish this one. It's not really that long. And next week we'll continue with unsupervised learning. Okay? All right. Let's have a quick 15-minute break. I'll see you guys at 4:15. Okay. All right. So that's enough for the break. Let's continue our lesson. Okay. Right. And to improve this. What? Sorry. Let's see. Collapse all code. Collapse all outputs. Okay. So this is where I will start. Okay, for our uh web scraping. Right. First is what website are we gonna scrape? Okay. Actually have this one here. It's books to scrape. Yep. So the last activity that you guys did was from Wikipedia, right? So this one is one of those sites that you can use to practice with, right? It's good to like go to these kinds of sites for now because they kind of um remove all the unnecessary things that we see on a normal website and focus more on the scraping part, which is the important one, right? Um, yeah, so the thing about this, it's a site that simulates a record of a lot of different books, and each book has its own information, like price, its stock, how many are available, the number of stars, description, the different kind of information that you usually see on a book. So, so these things could have been just like lorem ipsums, if you know what that is, but they made an effort at actually making it look like a bookstore, okay? A demo bookstore. So yeah, it has an add to basket button. It actually doesn't work. It just reloads the page. It doesn't really do anything, but that's not really the point of the site. The point of the site is to get all the data that you need. All right. So if you can do it here, you can probably do it with other similar apps that looks like this one or other similar sites that look like this one. Okay. So this is a static website. Okay. How do I know that it is a static website? Because no data is generated anywhere, any part whenever I'm interacting with it. All right. So interacting, for example, I'm moving the scrollable up and down like this one. Okay. Usually, like what you see on Facebook, I know that you've seen this one in Facebook. When you scroll down, right, it loads what the next few posts, right? And if you keep on scrolling down, it keeps on giving you new posts. But on the address itself, it's still the same thing. It didn't change. It's still the same address. Now, why is that? It's because behind the scenes, it's actually requesting for more data from Facebook, and then it automatically adds it to the page. So that is what we call a dynamic site. It dynamically requests new data from the server. This one is static because it's not doing anything. Okay. So that's one way of identifying whether it's static or dynamic. Okay. Another thing is that if you click on a book, let's say for this one, okay, it has its own address, tipping the velvet, something like that. If you go back to something, a different book, okay, it has a different address. Okay, so each book has its own address. Okay, now if this was a dynamic site, it would have been a generic address, like let's say per se a book, just a regular book. And the only thing that would change would be the data here. Okay, each time that you click on it, this is the only thing that would change. So the format is the same. The book picture will still be here. The price here, the availability, the stores. The only thing that will change will be what is inside of it, right? So it dynamically changes what you see on the page without actually you leaving to a different page. So this is actually more efficient in terms of data because you're only requesting what you want to see. You don't have to reload the whole page and everything on it just to view that one page. So it's more data efficient and data friendly, right? So that's one of the reasons why data is so economical nowadays because of dynamic sites. Um, but yeah, so what do we do? Our goal is to get all the books. This is our goal. We're gonna get all the books. In every category, we're gonna count the stars for each genre. We're gonna get all the total number of books for each genre, and then we're gonna make a graph out of that one and see which genre has the most stars, how many books have that many stars, right? Which genre has um actually how many different kinds of genres we have and the books, right? The distribution of books across the genres. Okay, so those are the kinds of data we can get and make a graph out of. Okay, okay. Let's see. All right. So first is we're gonna need the things, the libraries. Okay, let's start with PS4. I hope you guys still remember this one. So PS4 import beautiful soup. So the names are kind of weird, I know. But we don't really get a say on this on what to name their libraries. So import request. Let's name this one as R. Yeah, that's just R. Import. There you go. Import time, and then from IPython. This is what you guys use also as well, right? Display. Import SVG and display. Okay. Next is we can try and get the headers for this one. So if we press F12, and then go to, let's see, network index, right? We have the headers here. Now, the headers are what you send as well, so that they know kind of like basic information on you, like what are you trying to request. Usually it's the user agent. Where's the user agent here? This one. Um, what else? Chromium. Let's see. Yeah, this one you can go ahead and copy this one if you want. Uh, what else do we have? I guess this is enough. We can just use this one right now. So go ahead and copy this one. In our code here, we can put headers is equals to that doesn't work. It's user agent, capital A, and string. It needs to be a right. Next is, let's see. Let's create our function for the, yeah, let's create our function for getting the data from the books. Okay, so def get book data. Okay, what do we need to get the book data? We need the URL of the book, the address, and the headers as well. Pass our headers here on. All right. Um, First is we're gonna request the page. So we're gonna say page is equals to r.get book URL. So this is us, right? Simulating a browser that is trying to access a site, but it's actually just our program. Okay, that's what we're doing. That's what web scraping is. And then headers here is just equal to headers. Okay, so now we get the page, right? It should give us um, the HTML. So what we can do now is to pass it to soup. Sorry. Yeah, we can pass this one to soup. It's equals to ES, right? It's gonna we're create a beautiful soup object. We're gonna access page.content, and then we're gonna parse that one to HTML.parser. Okay, or you can use the other method that we used, the text one. That's also fine, as long as you can get the page, the HTML page, so that we can scan, go up and down the what do they call this one, the HTML tree. All right. So what do we need to find first? We need to take a look at our book. All right, so let's say, for example, an app like this is our page. This is our URL, right? That we're gonna pass to URL later on here. And then the header is the one that I copied earlier. Okay, now we're gonna go to elements. Okay, and we're gonna see, let's see. Okay. All right. So I think this is actually better than going into each book and then getting each data, right? All the things that we need is already outside here. So we have the rating, the title, the price, and the availability. If you want more data, then you have to access each book. You're gonna have to find a workaround for that. But in this case, this page is actually enough. So what do we need to do? Each book is actually just a list item, right? A list element in HTML. So that means all we have to do is look for all the lists classes, all the list items that has these specific classes. Because I think, right, based on what I see here, there's nothing similar around it that has this kind of format. So it's safe to say that we can directly just use this class as our search criteria, look for everything, all the elements that is like this, and then uh, use that one as our search criteria. Copy this one, right? I go to our code here, and I'm gonna say this is the list of all the allied items. And then I'm gonna say soup find underscore all the list items with a class underscore I did not copy that. This happens when I do not use the keyboard for a few minutes. Yeah. Here we go. So you should be able to find all the list items on our HTML, right? Next is what do? We need to get each one. So rating, title, price, availability. So how do we do that? So let's first create a list of all the data that we have. This will be a blank list for now. We're gonna create a loop. This is still in the same function. So data for I in li underscore list. So it's gonna track each one of the book, the list item, right? Um, so each one in this list is also a beautiful soup object. That means we can go ahead and use more. Um, you can use soup, beautiful soup methods to each item on this list. So that means if we say I here, right? And we're gonna look for rating. Okay. So let's see here. Where's the rating? Is that right here? Price, color, survey. Okay, this one. And it has the class of star rating. So we can go ahead for a look for a P. This is under the LI, right? We can go ahead and look for the paragraph. There's no other paragraph that I see here. But the important thing is the class because I'm pretty sure star rating here is unique. Um, that's not going to be used anywhere else. So let's see. You can kind of get the idea if it's unique or not based on the name. If it's something generic like column XX6, there's a higher chance that it's repeated somewhere else. But if it's a series of these things, right? It's a lot of, it's about four classes. So the odds of it repeating another section of the sites exactly like that, it's very low. So we can use that one as a search criteria. So again, star rating is an actually safe thing to search for. So we can go ahead here. We're gonna save this one into a variable called rating. I dot find. I is the item inside of the list. And this is a beautiful soup object, which means we can use the find and the find all method. So find and then P for a paragraph, mm, class, sorry, message. So we have class here, um, star anything dot get class negative. Okay. So why are we getting the negative one? Okay, because after getting this one, right, after finding the element, all right, star rating. Okay. So it will actually, if we get the class, it will give us a list object. Okay. And that list object has each class separated by a comma, all right? And if we use a negative one here, that means we are automatically accessing the last item on the list. The last item on the list in this case is 3, which happens to be the number of stars that is um, highlighted in the ratings. So this is what we want to get the 3. If you look at the other list items, all right? Let's try and compare star rating 1. Okay. So that is the rating of that book, right? So that's the trick here. We're going to use this 3 as the indicator of uh, how many stars for the rating is for that book. Okay. So negative. Um, Next is what else do we need? We need the title, right? So where's the title? The title is at H3. It needs to go to H3 and then look for A. And then from the A, we're gonna get the property called title. Okay, you can read that. So title is supposed to H, by the way, I dot by H3. Uh, then we're gonna find A as well, although it's just one. Find A and then get title. That's what we want. So that should be it. Mm, So we have the rating, we have the rating, we have title. What else do we have? We look for the price as well. So for the price, let's see. Price, it's this one. Mm, where is it? It's in the text property of the price color class of a P alphabet in HTML. So we're gonna use that one. So we're gonna say I that find. We're gonna look for a paragraph with a class of in stock. Oh, no, wait, price color. So price color. Then we can get the text that is inside of that. And then we'll just use the strip property and equal this one to true to remove all the spaces before and after the text. All right, that's for the price. And then availability. Availability equals to what? Let's take a look here. Mhm. So we're going to use this one in stock availability. I that fine. Oh, class underscore in stock and then availability get underscore text. Gonna strip it as well and set this one to true. Okay. So after that, we will uh let's see. Right, we'll save all of them into an object. Let's say title. This is what price star rating. Okay. And then 50. Okay. Next is we need to append the data that we just got. So data dot append to books from books table. Right. So now we have all the data here. It's gonna be set here to this list. So we will have a list of objects, and each object is a book with all these data in it. All right. And after that, after the loop is done, we can return data itself. So for each URL, that means what URL are we gonna pass? So we're gonna pass each URL of the category. So we're gonna click category travel and get all the books. Go to mystery, get all the books. Go to history fiction and then get all the books. So basically, if you take a look at uh, the URL here, it's actually pretty similar. So books, travel to, index HTML. Mystery, mystery 3, right? Everything else is the same except for this part, right? Take a look, right? History fiction, sequential art, classics, philosophy, right? So basically, we just get everything here and save it somewhere into our program. And I actually did this quite advanced, so we won't actually lose a lot of time. All right, so okay. Our URL is equals to URL. This is our URL. We're gonna save it here. And then we can remove this one and say something like insert here. We can search for this one later on and swap it out with the correct fragment of that URL. Okay. So where is it? Let me copy. Where did I save this one? All right, here we go. So this is all the URLs for that page. All right. Um, so I did this before and I save it as a list like this, but we can actually do this also programmatically. You can define a function for this as well. All you have to do is look for, um, instead of books, all you have to do is look for all the list items with it's here, those, yeah. So all you have to do is look for all the list items under nav list, right? And then after getting this item, you can go ahead and look for all the list items and then get the anchor tag and then get the href. So you get the href and then you get uh, the link. Okay. So instead of something like this, what you will do is you will get the this is two dots, right? Travel to so instead books is under books. So your URL will become something like this. Your new URL will become something like this. Okay. And then your segments will be a list. So we'll have segments here, and it will become a list, right? And each one will have a string for each link. Okay, so this one. So go ahead and search for nav list, you look for UL, and then each LI after UL, and then get each href. So the thing that will be saved here is something like this, dot slash / travel underscore two / index.html. This is what it would look like, right? Not like this. So this one, I made it into an object and categorize them like this, but you can do this in two different ways, right? Okay. So I'll just put some dots here as an alternate method. Okay. So, oh, it wasn't pasted. Uh, so I think so. Okay. So this is what it will look like. Okay, and then travel to this will be your new segments. Okay, but this is also okay, right? It's just more painstaking because we have to do it one by one. Um, but yeah, it looks a lot neater like this one. Okay, all right. So next is we're gonna combine this URL and this segment and then swap it out with the insert here. And then we get our new URL, right? And we can all save that one into another URL list here. So let's say all genre, and then we can put it here. Okay, we can create a loop for key value in URL segments. Was it a capital S? Yes. Segments. We're going to use the items method for this one. Okay. So we're going to get the this one to the key and then this one to the value. All right. So all genre dot URL underscore URL and then key. We're going to create a new object here, a new item in this object using the key, and then URL dot replace. The value for that key will be the URL with the replaced segment here. Okay. So replace and then insert here with the value that we get. So that's the loop. Okay. And after that, we will get all the links, all the new links here. So actually, if we want, we can print. Let's see. Let's print all genre underscore URL. Let's try and see what it will show us. Okay. So there, I think I'll just transfer this one here. Just to avoid making a mistake. All right, let's see. URL HTTPS undetermined string line 41. View where is the number? Show line where is 41. All right, this answer we needed. Okay, now as you can see, it's a little bit messy, but this is the link for travel. This is the link for mystery. As you can see, it's interactable now because it's a link. You can click on it directly. So if we try travel, it should take us directly to travel. See, it's like we are clicking manually on that link on the site. Okay, so we have all the links now properly configured. All right. So now, what do we do next? right? So after this, let's go ahead and scrape out the data. All right, so hmm, okay, we'll try and get all of the info. So we're gonna save it into a new object, all genre info, and then okay, for genre and then URL in all genre underscore URL dot items. Okay, okay. So we get the genre, we get the link URL. So we can now get the data, right? Using our function that we created earlier, this one, get book data. We can call that now and save it somewhere. So let's save it into data, get book data. We'll pass in the URL that we have and the headers that we created earlier. Okay. Next is after getting all the data, all the books on that page, all right, under that category, we're gonna save all that info now to our new list, all genre.info. We're gonna use the genre name, create a new uh, item for that object, and then we'll put all the data there, pass it there. Uh, Allow some leeway for the site to respond before accessing or giving it another URL. So you can say time.sleep too before doing it all over again. After that, we should have uh we should have all the books. So if we try and say print, right, all genre underscore info, and we're gonna say access travel, we should see all the books that it has collected. Let's go see. So this probably take a while because it's trying to collect all the books and we're just trying to take a look at one, but that's okay, right? I think this should be enough for today after printing the output. We're basically halfway there anyway. Um, so I think around 30 minutes next week should be enough to finish this activity. All right, let's just wait for the output, guys, and then that should be it. Hopefully there are no errors. If I do get an error, then everything will stop because I did not put any um, error handling in this. Hmm. All right. So if we go now to travel, right? Let's see what are the books here. It's Only the Himalayas, Full Moon Over Novas, See America, Celebration, Vagabonding. Let's see our results. It's Only the Himalayas, star rating, price, availability in stock. We have Full Moon Over Novas. We have See America and then Vagabonding. All right. What's the last book here? The last book is A Thousand Places to See. The last book that we got is A Thousand Places to See Before You Die. All right. So we know that we actually got the correct info and then save it to this object here. So odds are, for all the other categories, it's also saved here if we access them. Um, all right. So we'll continue this one by next week. Um, but yeah, there's only a few steps left since we already got all the info. All we have to do now is process the data and then sort them out, put them on a graph, and then that's done. Okay. So again, let's see. Before you leave, just like last week, I'm gonna upload on the LMS the recording of the session, the files that I'm using, this one, the notebook as well, so that you can get a reference of it and what I was typing, and also to simulate on your end if it works, if there's anything missing on your Anaconda libraries. Okay. All right. Any questions before we end? All right. So I'm gonna take that as a no. Okay. Right. So that's it for today, guys. Thanks for listening. I'll see you next week. Goodbye.